Hello everyone, welcome to our space together with OpenZeppelin about the new release of the OpenZeppelin library contracts version 5.1. In this version we have so many new features and changes and technology that was introduced to the contracts and to the library, and we have here together with us two developers from the core team from OpenZeppelin, Monchi and Hadrien. They will tell us more about the new release of the OpenZeppelin contracts, which you probably know that they are like very widely used in the space. Even the FBI are using OpenZeppelin contract, by the way, if you didn't see the last post. And this is the new version, and today we're gonna talk about this new version, about all the new features and ask questions, and gonna be super insightful. So stay tuned. And before we start, I want just to have a quick introduction of the speakers. So we have Monchi. Monchi, feel free to speak. The mic is yours.
Yeah, perfect. All right. Thank you, Johnny. Excited to be here. I'm Monchi or Cairo, and I'm a contributor to OC contracts, especially with a background on DeFi. And I enjoy working on low-level EVM libraries.
Very cool. Adrian, feel free.
Yes, I'm Solidity developer for quite a while, started in 2017 and been working at OpenZeppelin on this contract since 2021. So yeah, quite a while now. I don't think I have any particular specialties. I'm interested in basically everything that is EVM related. Obviously looking a lot towards like the evolution of the chain, but yeah, building contracts for a living.
Beautiful. Thank you so much, guys, for the introduction. So please take advantage of the fact that we have here two OG hardcore engineers from the OpenZeppelin team that are actually working towards like contributing to this library, to the libraries and all the contracts that you're familiar with, from ERC20 to Merkle trees. And today we're going to cover all these new features. So let's just start with a quick overview of what's new in the version 5.1 in the new library. So Monchi, can you give us like a high level overview about this release? What kind of challenges and issues you were trying to tackle, and what kind of main features were introduced and changes to the contracts?
Yeah, sure. I think in general, like version 5.1, it's a relatively big release, considering it's like a minor version. There's about 40 changelog entries, but in general, the motivation was mostly to expand and improve kind of like three main areas. It was cryptography, data structures, and utilities. For cryptography in specific, the goal was basically to provide support for a couple more curves beyond the traditional curve that Ethereum is built on. Ethereum is built on the SECP 256K1 curve, but additional curves like the same one, but the R variant are just more widely used and supported by, let's say, secure enclaves in mobile devices, like the Apple secure enclave. And there wasn't a Solidity implementation that basically implemented this curve in Solidity and also supported the RAP 7212, which is basically a precompile that is implemented in a couple of rollups, but not all of rollups. So having an implementation that basically supports this precompile and also has like a Solidity implementation that can back this precompile if it's not available, would be super useful for developers. Similar to this, an addition also in the release was an RSA verifier contract, which is also similarly, useful for in real life related applications. In general, like these changes and additions to cryptography are pretty useful to support account abstraction and also a couple of like CK related applications. For data structures, the goal was mostly to answer and just implement long-awaited requests. This include, let's say, sort functions for memory arrays, but also provide Merkle tree structures, which are pretty useful for CK applications. These were introduced, I believe, by Tornado Cache, but also has some applications in building rollups, as they're particularly useful for batch exits, for example. A couple of other data structures that were also included were, the circular buffer, which are, it's a nice data structure for constant time insertion and deletion. This is pretty useful for, let's say if you want to have like events or data with minimal gas cost, especially, useful in DeFi applications. And similarly, we also introduced like the heap structure, which optimizes like priority-based tasks like a queue, or if you want to do an on-chain auction, the heap would be, probably one of the best approaches to doing that. So in general, like, part of the new additions in the release lay the foundation for a couple of exciting roadmap initiatives that we're working on, and the modifications or the updates to the existing, libraries in the contracts repo were just based on community feedback and improvements. Hadrien, I don't know if you have anything else to add here.
Yeah, just saying that the last release really was 5.0. We've had a few security patches, but the last big release was 5.0. It was on the October 5th, 2023. So it's a year of feature that we are shipping right now. So like obviously, like as Monchi said, there are a lot of features that are aligned with what we feel the ecosystem needs. For example, cryptography for account abstraction, but it's also basically like everything that we came around for a year in terms of features. So a lot of optimization, a lot of small change, a lot of improvement, and as Monchi said, a lot of small utilities. So basically, all developers may find something that they find interesting for their use case.
It's very exciting. I know that OpenZeppelin contracts are a real part of this ecosystem, and I guess every other app, if not like 80% of the apps, are using them. And it's just natural that the contracts and the library evolves over time. And it's very exciting to hear how you guys add support to the new developments and the new changes in the ecosystem. We see like that a lot of volume and liquidity is moving to layer 2s, and these layer 2s are usually natively supporting account abstraction and signatures using mobile phones. So we need new cryptography libraries. So it's really interesting. And by the way, this is just an intro, guys. We're gonna dive into every single change in these library contracts. And if you're like hardcore into Web3 development or to smart contract security, this space is a must, because there is a lot of value here to derive from the space. So let's just start like step by step, talking about these new changes that you guys just gave a quick overview. And we'll start with the utilities and the tokens. So we have some additions to ERC20, and we have also the ERC1363, right? Which is a new kind of a standard that was added to the library. So Hadrien, can you please explain a bit more about this new ERC that was added?
Yeah, so I mean, it's not really a new ERC, like just running the number 1363, like you can understand it's quite old, but it was never merged into the repo for many reasons, and we finally did it. So I'm happy with that. So the main point of 1363 is to provide better mechanism for transferring tokens and reacting at the same time. Most users of crypto, of DeFi, know about the painful process of first having to approve a contract and then spending your allowance. For example, you want to do a swap on Uniswap or any other market. You need to first like approve this market to spend your USDC, so that then you're able to sell it for any token you want. And that's kind of painful, and like the allowances can stay, like sometimes you allow too much, so that like you're happy for a while, and like if you want to do another trade, allowance is already set. But then if there is a bug in the contract has an allowance, and you can lose token, and a lot of token have been lost that way. And so what 1363 proposes is a way so that instead of first going to the token and asking for to set an allowance, to approve a spender and then go to the spender, you can directly go to the token and tell the token, I want you to transfer that amount of tokens to this person, and notify them at the same time. And that notification is what allows everything to happen in like a single transaction, in a single flow. Unfortunately, like that, this only works if the contract that receives the token has the ability to react to that notification by the token. So I'm not. We don't foresee any like drastic change in the space because most tokens don't have that feature, and so most exchanges and systems don't assume this feature exists, and so they don't take benefit from it. But hopefully, at some point, like more token will ship with this feature, and more DeFi projects will support it, and we'll have more seamless integration to some extent, and more user friendly workflows.
This is very
that's
interesting.
the idea. There are competitors like alternative approach to 1363, but our understanding is that 1363 is the one that is the most well written and also that follows the ERC track well. So yeah, we are very excited to see people adopt it.
This is super insightful. Thank you, Hadrien. It's actually interesting because I wasn't familiar with this EIP, and it's kind of competitor to the permit kind of approach because we have the ERC20 permit where you can just sign a message and then give it to the contract that is going to spend the tokens, right?
Yeah, to some extent that's true. I mean, the permit allows different processes. The permit allows someone else to relay the message. 1363, you have to relay the message yourself and you have to pay the gas. But on the other hand, the permit will set an allowance that may stay for a while. You don't know how it's going to be used necessarily. So there are different approaches.
Interesting. That's really interesting because so now you said that essentially this will be available for developers to use, but it will require a lot of protocols and token deployers to just use the standard. So it's available for them if they want to use it, but it's probably going to take some time until people will start using it and adopt it. So just so you know, guys, this is available now. If you're deploying a token, if you're creating a new protocol, you can receive this callback to be notified about this kind of deposit or whatsoever deposit or withdraw collateral, something, whether it's an AMM or a lending protocol or any other protocol. So it's a very cool kind of token to add to the arsenal and to the library.
In a composable manner, as you present it with AMM and all other projects like that, it will take some time, but it is very easy for like a game project to start adopting that right now and have their token for their game and their contract that spend the token for their game both supported at the same time, and they can ship that very fast.
Interesting. By the way, so this introduced a new callback, and you know me, I'm like in like the attacker mindset, and I'm paranoid all the time every time I hear about callbacks, especially when they are natively implemented inside tokens like ERC777, which opens a lot of possibilities for reentry attacks, for example. I'm just curious, like this kind of standard impose any security risks for protocols, or what do they need to be? What do they need to take care of? Like, what do you need to consider while using it?
So the receiver has to be careful that the callback he receives comes from the actual token and not from someone trying to impersonate that. That's the receiver side security. On the token, like the sender side of the call, because it's a very specific function selector that is being called. It should not be possible for someone to leverage that to have the token call basically anything and do bad things. So I think from the token point of view, security is pretty good. It's really the receiver that have to be careful what they accept through that endpoint.
Cool. So guys, if you're developing some kind of DeFi protocol and you're supporting this kind of new standard, not very new, but new in the libraries, you need to make sure that there is a callback and you know, the order of execution and the state management always follow the CEI pattern as much as you can, or use some kind of reentry protection by OpenZeppelin, the reentry guard, which we'll talk later on in this space because it also had some changes regarding transient storage. By the way, Monchi, do you want to add anything regarding this standard, the ERC 1363?
No, I don't have anything to add specifically here.
Cool. Awesome. And the next introduction to the addition to ERC20, which is also kind of like attacks the same problem with approvals, but in a different angle. We have the new temporary approval, which you personally worked on, right, Hadrien? The ERC20 temporary approval. Can you tell us a bit more about this new addition?
So again, this is also trying to think about new ways to make things both less expensive to run and safer. And again, like not having allowances that stay for a while on chain that can be exploited. So we have this new thing that is transient storage that was released pretty early, like not long ago. I think it was in Cancun. So some chains have it, some chains don't have it. But for chains that have it, you have the ability to set an approval that will only last for one transaction. So that's not really useful if you're an EOA. Like if you have your MetaMask and you want to do something, you're not going to be able to leverage that, at least not until you have some kind of batching capability, possibly in the next hard fork with 7702. But if you're like a smart contract, like some kind of DeFi project that sets an allowance and then calls someone to spend it, if you know the token you're working with supports transient this EIP, this ERC, and you can basically use it. And the good thing about this ERC, I think, is that the receiver of the token doesn't need to know about it, just the person that sends it. So again, it will take a while, I think, for it to be adopted and to be used for general projects and DeFi. But again, in a context, as I said, where a project basically controls everything from the token to the spender, for example, in the case of games, I think it could be adopted pretty fast.
Very, very cool. Actually, when I read about this ERC20 temporary approval, the first thing that crossed my mind is like approving someone to spend my tokens for a certain amount of time, like 1 day or 1 week. But now I understand that it's only during the same transaction atomically, which is thanks to transient storage, which we're going to talk a bit more in the next section. Interesting. By the way, did you guys consider to introduce some kind of temporary approval that is expiring in, 24 hours, like some kind of timestamp? This actually could be interesting addition to the EAP. I don't know if it exists.
Yeah, so we consider that, and we also considered implementing a temporary approval like this one that expires at the end of the transaction, but that is based on normal storage instead of transient storage for chains that don't have transient storage yet. In both cases, it's really like storage expensive, and storage is super expensive, and it will just become more expensive with the Verge. So we try to avoid having too many storage operations. And like if people request that feature, we can definitely work on that, but we'll have to understand how much it costs and what really the use cases are.
Cool. There are many attacks where, like, there is like an approval where it wasn't revoked, like unlimited tokens approval, and then some kind of router or periphery contract is being hacked, and then so many users lose their money because they just gave approval of, unlimited USDC tokens, then the attacker just drains their USDC wallets. So this could be a great addition to implement when it comes to using ERC20 tokens. But again, it requires that everything will be atomic. So it's more for like chains that support, first of all, transient storage, because it's a requirement. And also, I guess, some kind of batch transactions, right? So we can do this approve and whatever operation in the same transaction, correct?
Yeah. I mean, and any change to the ERC flow is going to take a while to be adopted anyway. Like developers are so familiar with the old flow that dates from 2015, I think, and that is somehow insecure. But that's what people are used to having, and I think it will stay like that for quite a while.
Yeah, it's very interesting. It's like so, integrated into the ecosystem. There are so many tokens and protocols that use the standard. So introducing a change is really challenging. That's why I can imagine how hard it is to add changes to this EIP20 standard or to the ERC20 token. All right, moving on to transient storage. So everyone probably heard about transient storage that was added in the recent upgrades to Solidity. And of course, it creates a lot of new use cases, and a lot of contracts in the library were affected. For example, the reintroduction protection contract, and I guess other contracts as well. So Monchi, can you please enlighten us regarding just a quick overview of like what is transient storage and what kind of changes were added to the recent version to support or to take advantage and use transient storage?
Sure, yeah. So, transient storage, it's basically offers a way to store data temporarily during a transaction. that's kind of basically the primer on that. I think that the main takeaway is that, I mean, it cuts down on gas costs significantly. One example of, like a use case that is unlocked by the efficiency, it's, let's say like Uniswap V4's flash accounting system, which basically depends on transient storage and wouldn't be practical in terms of cost if it wasn't done with transient storage. So basically, in that case, instead of transferring the tokens in and out the pools at the end of every swap, you just have like a transient net balances that basically are consumed at the end of the transaction to transfer out the tokens, and then after that, it's just they get cleared basically to zero, and it just allows for a more efficient system in terms of like swaps and also liquidity provisioning. In terms of our library, Hadrien was just talking about ERC temporary approval that is basically running on top of transient storage, and wouldn't be possible without transient storage. And similarly, we also implemented reentrancy wired transient, which is similar to reentrancy wired, except that the flag, which is the entered flag, to basically tag if a certain function was already called or not. Instead of being persistent in terms of storage, it is now basically managed in a transient way. I think I read somewhere that this mostly allows to like a 90% reduction in terms of gas. Specifically the gas that is, consumed for this, for marking the flag compared to the normal reentrancy guard extension. So in general, I think in general, it's a, pretty nice thing to have. And, depending on the use case, could unlock certain things. So, from my perspective, I'm kind of expecting, people to like slowly switch to use like, reentrancy wired transient. And the reason is just it's much cheaper and the behavior is mostly the same.
Amazing overview. Thank you so much, Monchi. Indeed, there are so many use cases for transient storage, and it's way cheaper than storing data forever on the blockchain, of course. Reentrancy is a great use case because the reentrancy flag doesn't need to be stored like forever and changed in the contract forever. It's enough to remember the flag in an atomic way during the transaction. That's the whole idea, that in one transaction, a malicious user will not re-enter again and again to different functions in the contract or group of contracts if it's a cross-contract reentrancy. So it's a very great improvement to reduce the gas cost for reentrancy. And I didn't imagine it will be 90%, but that's a lot. That's amazing. Just another use case that comes into my head right now is like a lot of times you encode and pack data for callbacks, right? If it's like, let's just take the most basic example of like Uniswap V2 flash swap, where you just pass some data that is coming back to you rather than in the callback. So I think in transient storage, a lot of cases you can just store some data in your contract, and once you receive the callback, access this transient storage, and instead of just passing, also for like the simplicity of developer, instead of just passing data from contracts back and forth, they can just receive it, just store it in transient storage, and then access it later. Any thoughts?
I think it would be, Hadrien, maybe it would be interesting, your perspective in terms of like security, based on like the solidity underhand competition, and maybe like some of the pitfalls or things to avoid with transient storage would be interesting.
So I mean, I was a judge of the solidity underhanded context that happened a few weeks ago, and that was specialized on transient storage. In my opinion, the biggest security pitfall right now is that it's not well supported by the compiler. I mean, version 0828 just shipped with support for value typed in transient storage, so that's good, but it's very far from what projects like Uniswap need, for example, like with the flash accounting that needs mapping and things like that. So I think the first thing that we did, because we discussed where we use transient storage, but a lot of the work we did is also making it more easily available to developers that want to work with it. And we have this entire library that is dedicated to helping developers manipulate transient storage, write to it, read from it, and build equivalent to mapping and arrays and things like that. So I think that's also something quite important for us is allowing users to work with it. Now, once you are out of this pitfall of like you have to write in assembly and that's complicated, the other pitfalls are basically about some assumptions that people make about transient storage, that when you start your operation, it's free, it's clean, it's zero. Well, it is if you know that you're at the beginning of a normal transaction, but we're going to see more and more smart accounts do user operation that are batched together by an entry point following 4337. And in that case, any operation may leave dirty transient storage that will not be cleared until the end of the transaction. So the next user operation will have dirty transient storage if it's not cleaned. So that's one of the concerns of the Solidity team and why it takes so long for them to find a secure way to put it in the compiler, a foolproof way. So that's what you have to be careful about. It's like when you build an application, really think of what you're leaving behind in terms of transient storage that you expect to be clean at the end of the transaction, and what happens if you rerun the same or another operation with that dirty stuff still there, because it could very well still be there.
That's very interesting, definitely. So transient storage is not very straightforward, and there are probably going to be many pitfalls that developers can make mistakes, and the results could be catastrophic. But it's a very cool addition to the EVM, in my opinion. And by the way, guys, here in the crowd, if you want to ask questions or give us some examples on how you're going to use maybe the new features like ERC 1363 or the temporary approval, feel free to share them. Just comment to this space. Maybe you can also request speaker permission if you want to ask questions, Monchi or Hadrien. So we can give you like the stage for a while if you're curious about certain things. So we can definitely talk for 1 hour just about transient storage, its use cases, the pitfalls, but we have many more interesting subjects to move on. So we will move on to the next one, which is essentially the new data structures in the libraries. So there were new data structures that were added to the libraries. Some of them also to support and pave the way to the upcoming Verkle EVM. So, Monchi, I will ask you just a quick intro. What is the Verkle EVM? Just 1 minute, maybe. What kind of new data structures were added to the contracts, and why? What's the reason? What's the thinking behind like adding those data structures?
Sure. Yeah. So, Verkle EVM is, I think, like, I guess more specific name would be kind of like the Verkle tree transition. It's kind of like, this idea of, aiming to scale by basically optimizing how data is stored and accessed, in terms of contract, smart contract, storage. The idea is that, basically like Verkle trees improve on Merkle trees, which is, the current approach, by basically being more compact and allowing for much faster proofs, especially when verifying like large sets of data. In terms of like the data structures in this release, they're not for Verkle tree. They're just designed with Verkle tree in mind, in case whenever the transition it's made, and that is basically reflected on how the storage layout on these data structures is defined, also updated and consumed. So it was a bit of a mostly on the design perspective, to basically get ahead and make it basically well designed for this potential upcoming Verkle tree transition, basically.
Cool. Hadrien, you were also one of the developers that work on that. So do you want to expand a bit about how was it to develop it, and like what kind of changes did you add? Okay, so what I wanted to say is that Hadrien, you also participated in developing this new heap data structure. So do you want to expand a little bit?
Well, the new data structure we have, basically for those that are not really familiar with the consequences of the transition to Verkle EVM to gas storage, the thing is that it's going to be way more expensive to access random individual slots and way cheaper to access contiguous slots. Way cheaper. And the thing is that we are used to using mappings everywhere, and mappings go to random places in the storage space and are will become very expensive with Verkle. So the question is, how much can we transition from using mappings to using arrays? There are cases where it's quite hard. The language has some limitation. But in this release, we have a few data structure that we could basically implement with both approaches. And usually we do a lot of mappings, and it was just like trying to see how we can do it differently this time. And it's not necessarily very challenging. It's just it's like some kind of objective to use a different approach. Sometimes it's a bit more expensive on some aspect, like when you delete stuff, you have to move stuff around so that the data stay contiguous. But it's not that big of a deal. I think it was very interesting. But the main challenge will come when we move to, because like doing that, like using arrays for the heap structure, for the circular buffer, even for the Merkle tree, was kind of easy. Their structures are very well adapted to this kind of access storage. The real challenge will be seeing how we can improve on what we do, for example, for storing ERC20 balances or things like that. At some point, we want to make that more Merkle friendly. I don't know if it's possible, but we'll definitely try, and that will be the challenging part.
Wow, it's really interesting because I know that mappings are very strong foundation in a lot of smart contracts. Like you said, even in the ERC20 balances and allowances, it's a mapping. I can't imagine moving it from like a mapping to an array. You know, it just sounds like a mission impossible. So how do you imagine it happening?
Well, the first thing is if you have multiple mappings that have the same key and that are accessed at the same time, maybe it's better to have one mapping that goes from this key to a structure where it's contiguous, as opposed to having two independent mappings. So that's the first thing we can do. We can do that in ERC 721. I showed how this could improve the Verkle performances of NFTs of ERC 721. Yeah, 721 in my ETHEC talk, so that's maybe available somewhere on Twitter, on YouTube. So yeah, that's the first aspect. It's trying to consolidate existing mappings. Beyond that, I'm not sure it's actually possible. We'll see.
It's interesting. So you are kind of like preparing the ground for this kind of change, and when this change comes, it means that the gas consumption for storing data in mappings, which is like in random not random, but not like, you know, not incremental storage slots, it's going to be way more expensive, and we need to kind of like prepare the ground for that. That's what it means, right?
Yeah, and it's not just preparing, it's also like people are going to deploy contracts today, tomorrow, in a month, and they're not going to redeploy everything after the verge. At least we hope they don't. So we're not going to wait for the verge to happen to ship optimized code. We want to ship it as soon as possible so that people start deploying it, maybe not noticing that it's optimized for the verge, but in a few months, in a few years, they will be thankful.
Very, very cool. So from talking about Verkle trees, let's talk a bit about Merkle trees, which are very useful, not on the, I would say, like the EVM and state changes of the blockchain itself, but to verify data, and they're used quite often when it comes to airdrop or to prove something. You get some kind of proof of chain, and then you prove it in the smart contract. And we have also the Merkle trees library that had some changes. So Hadrien, can you please tell us like what kind of changes in terms of if it's like gas efficiency or like user experience were introduced to the Merkle trees library?
So it's not even changed. It's a brand new library. Because cool. we used to have and we still have the Merkle proof library, and the Merkle proof library is helping you prove something, provided that you have the root of the tree and basically a proof of inclusion of a leaf. And the Merkle proof library has been here for a while, and it's what you'd use for like proving that you're part of an airdrop. For example, I remember when there was the ENS token that was distributed, basically what happened is that some authority, in that case the ENS Foundation, curates a list of recipients for the token, and they build a Merkle tree out of that, and they do that off-chain. They do that on their laptop using any library, and we have a JavaScript library for that I encourage everybody to use if you are doing such an operation. And they do that on their machines, and then they get a Merkle root, which is just a byte 32, and they put that in their contract. And once they have that in their contract, they can use the Merkle proof library to prove the inclusion of anybody. And that's what happens when you or I go to this contract and say like, hey, I'm entitled to that many tokens. Here is the proof. And it's going to be proven against the Merkle root. The new Merkle tree library is different in the sense that it's for building the Merkle tree on-chain. Instead of building off-chain, the Merkle tree library, it's a data structure that allows you to say like, hey, I start with an empty tree, and I'm going to add leaves. And each time you add a leaf, it will recompute the root of this tree. And that allows you to keep basically on-chain a small footprint that just a simple byte 32 that contains a list of everything that was added to it. And you don't have to know exactly what was added. You just have something that you can prove later. And I think this data structure was introduced in Tornado Cash a while back. And Tornado Cash used that so that whenever you would deposit assets to the system, it would put a leaf somewhere saying like, hey, this was added. And then the entire system of Tornado Cash was proving you're part of this was possible using a ZK proof that would hide which leaf you are actually using. So basically, we're implementing this data structure, and it can be reused to rebuild Tornado Cash, even though there are better designs today. But we also think it can be used for in the context of cross-chain communication, where you could like have the system aggregate data one after the other, and you would put everything on a Merkle tree on one chain, and then at some point you would just communicate the root instead of communicating everything. And so you would reduce the amount of communication between chains. And on one chain, basically, you would use the Merkle tree library to build a tree. And on the other chain, you would use the Merkle proof library to prove what was included.
Wow. It's really interesting. It's a bit like, for me, it's like a bit confusing because, I saw a lot of contracts that use the Merkle proof library. And usually the root hash is in the state. It's like either hard-coded or like some kind of storage variable that can be updated. But in that case, if the Merkle tree is dynamic on-chain, it means that every leaf that is being added, all the hashes are being changed, including the root. So the root is dynamic, right?
Yeah, so the thing is that you don't have to store all the intermediary
exactly
node.
Only the root. Only the root.
So we do that. So you need to store some stuff along the path from the last leaf to the root. But so you would update that and we would give you the next root. And basically each time you add a new leaf, you would get a new root. And so you can just like keep just one root and say like, here I'm replacing it. Or you could use the data structure that we call circular buffer to say like, hey, I'm going to store like the last 10 roots so that I have some history. That can be useful if someone wants to prove something. Someone else inserts a leaf just before, the proof becomes invalid. So if your proof is recent, you want it to pass. So you may want to keep 5, 6, maybe 10 Merkle roots as a buffer. So that's why we have the circular buffer also. They work hand in hand.
Can we also remove existing nodes from the tree, or this is impossible just to add?
No, this is not possible. It's a very interesting challenge. We would like to be able to do so, but now that you're saying it, like, given that if you have a proof of the leaf, you may be able to do it.
Interesting.
If you have a proof of the leaf, you may be able to do it. That's quite interesting. If you want to implement it, or if anybody listening wants to implement that, contributions are always welcome.
Guys, the best way to contribute to the ecosystem is to contribute to the OpenZeppelin library. So if you want to mark your name in the space, feel free to check out the library and introduce changes, upgrades. It's open source. It's an amazing contribution to the ecosystem by OpenZeppelin, but it's essentially open source, so anyone can contribute.
And about that, I mean, we value all kind of contributions. Ideally, we prefer people coming to us with ideas, with use cases, with documented things that they want implemented, and then we can start discussing from that and trying to find the best possible implementation. If people come to us directly with implementation,
that's suspicious.
We want to go back to. I mean, it's not that it's suspicious. We want to understand how it will affect the ecosystem, if it's going to be meaningful for everybody, or just for their particular use case. That's why we always want to go back to what is the problem that is being solved, what is the use case. And also that means that people that are not very good Solidity developers, but that have ideas, provided that the thing, their idea is kind of universal, it applies to other people as well, they can contribute. And we have been awarding, so it's POAF badge, it's not big value, but we've been awarding POAF badge to contributors, and that includes people that were just raising good issues on the repo.
100%. Monchi, can you think about potential issues when it comes to managing, I don't know, dynamic Merkle trees on chain when we can just add leaves, or what's your thoughts on that?
I think like Hadrien covered on chain. I think, obviously, like, in the case of airdrops, claiming, let's say like an airdrop based, on that, you should expect the UI or whatever interface or app you're using, to basically build the transaction to claim for you, should be able to basically also, update or basically point to a new route in a dynamic way. There's like many, there have been many cases where, for an airdrop, a team develops a UI, but then they want to switch to a different method route, and it's like a whole, manual process of updating everything, so that it matches, let's say the new route. So if now, this is dynamic, the developers should make sure that, the UI is also able to catch up with, the state of the contract, like the route on the contract, and then, be able to generate basically, the claim transaction with, a valid proof for the latest route, basically. So that would be kind of like my take on that.
Cool. I think until now they had like some kind of an array of like multiple routes, and anytime they wanted to add new people that are eligible for the airdrop, they would just add new routes, right? And now it's not necessary, because now they can just add nodes to the single route. You can just confirm my thoughts or reject them. I don't know.
Yeah, no, I mean, you don't want to add people one by one, because that would be way too expensive. But the thing is that if one of the leaf of a Merkle tree is the root of another Merkle tree, you can change the proofs. So you can imagine having a Merkle tree structure on chain, and what you add to it are roots of smaller Merkle trees that are possibly computed off chain. And that would build some kind of a forest that has a single big root. And that means you could add small trees to chunk of a lot of user in one single transaction, and you would keep the same proof system. So you can have a hierarchical system like that. So yeah, you can be very creative.
Cool, very cool. Okay, now to the last subject of today. Now I want everyone to imagine going to the next grocery store, taking their mobile phone, whether it's, let it be Android or iPhone, buying, I guess, milk and Coke Zero, and then paying with their whatever MetaMask wallet, with their Face ID, and getting their groceries, right? Sounds like a dream, but the dream is getting like closer and closer to reality. And in order to support this dream, that you can pay, like I would say, from your mobile phone and Face ID together, this kind of flawless user experience that you have with credit cards and Apple Wallet or whatever, Google Wallet, we want to support it also for crypto wallets, for like MetaMask or like, I don't know, Argent in Starknet or whatever wallet you use. And this is going to be possible soon. It's actually possible for certain wallets, but it requires some changes or additions to the signature schemes, because these mobile devices use different signature schemes that needs to be supported. And this is going to be the last subject for today. So Monchi, can you add a bit more about the enhancement for the signature schemes that are supported in the OpenZeppelin contracts and how it will contribute to a better UX in the future when it comes to supporting different signatures?
Yeah, sure. I really like the example that you gave. Yeah, so so I think over past, in general, like the curve, the cryptographic curve that has been used, in Ethereum, it's different from the one that is used in, other, let's say like consumer, hardware or even other applications. So there's always been like a mismatch in terms of compatibility. So the idea for this release was basically to incorporate the other curves and basically enable builders to create applications kind of on top of real world infrastructure. One example is the Apple Secure Enclave. I think you can also do like corporate public key infrastructures in smart contracts with these new curves. Specifically users can find the P256 and the RSA libraries for signature validation. For P256, it implements the SCCP 256R1 curve for verification and recovery. And for RSA, the RSA PKCS1, I think it's the version 1.5 signature verification. So you kind of have like those two main, additions in this release. I think, some of the use cases that are really exciting is mostly, on wallets or even passkeys. So, you have Dymo, or now I think there's like the Ithaca demo where, you don't even need like a wallet to send a transaction. You can just, use your, device passkey. So if you have a Mac, you can, even use like your, Touch ID, and basically you just sign a transaction with that. You don't even need, to have a wallet, right? Assuming that, let's say, a sequencer or another, user sponsors your transactions. So I think like all of this is, is going to lead to, better UX experiences and abstracting all of, these like gas mechanisms or private key away from the user, which are, honestly, like, signing, malicious approvals or permits are, I think, like one of the, main reasons of like draining wallets. So you're able to kind of like abstract all of that away and, kind of have like a, easier and also, by effect, a more secure approach. Is just going to be better for users. So there's here a ton of things to build, especially related to account abstraction. So I think those are kind of the things that unlock, and we're excited about.
Very, very exciting. Hadrien, do you want to add something?
Yeah, just that this is for us just a first step. We want to. I mean, as we all know, like account abstraction is really big and coming. I've said that for a while since it was named meta transaction, or I don't know how it was called back then. But yeah, the idea is that we want to provide more tooling. We want to try to support, to provide basic building blocks for this ecosystem to thrive. And so like the cryptographic libraries are really the first step, but for us it's just an enabler for what comes next into 5.2, 5.3 and so on.
Very, very cool. Thank you so much for expanding on the matter. All right, so to recap what we had today, we talked about the new release, the OpenZeppelin libraries 5.1, the new version since last year. This is the most recent major version with so many upgrades. We talked about the ERC 1363. We talked about the ERC 20 temporary approval, the transient storage and how it affects the OpenZeppelin library contracts, the new data structures, the heap structure, and kind of preparation to the Verkle EVM, but generic improvements in those data structures, and of course about the cryptographic enhancements, the new Merkle tree contract, and the new signature schemes. And I just want to say that this is just the tip of the iceberg. We didn't cover everything. It's a huge release, and I really recommend you to go over right now to the OpenZeppelin Twitter account, and you will find there a huge thread with all the details about this new release. Of course, these threads also forwards to to a blog post with more details, and even there is also a page on GitHub with a markdown page with all the changes and new additions. It's way more than what we covered. So if you're like a serious hardcore Web3 developer or security researcher, this is something that you definitely don't want to miss out, because this is going to be the future. You already know that almost every project is using those libraries, and these libraries shows, like, these new features show how Web3 is going to look like in the future. So if you want to learn more about transient storage, about those cool new features, definitely go ahead, check out the thread, check out the blog post and the new release markdown page on GitHub. And of course, if you want to contribute, it's an open source project led and managed by OpenZeppelin, but you can add your contribution and contribute to the ecosystem and to the community, and also create a name for yourself, right? This is, by the way, I always say that this is the best way if you're looking for a job or you're seeking like new opportunities. One of the best ways to contribute to an open source project. And what's better project to contribute to rather than the OpenZeppelin library contracts, which is one of the best public goods that we have here in the space. So thank you so much, guys, for being here. Thank you. Thank you, Monchi and Hadrien, for sharing your experience and knowledge with everyone. Thank you, everyone, for participating. And if you want to say final words, that's the time. Monchi, Hadrien, anything to add?
No. Thank you very much for having us today. I hope everybody. I'm not sure if we even mentioned that, but 5.1 has been in release candidate for 2 weeks. There have been a bonus on the bug bounty during the release candidate. That bonus is no longer live because the final release was done this morning, like a few hours ago. So as of today, 5.1 is fully live. But again, if you find any bugs, please make sure to report them on Immunify. That's also a very good way to prove your skills to the community and to future employers, and also to make a pretty penny on the way.
Very cool, very cool. So there is a bug bounty program going on Immunify with the libraries, with the contracts. It's not going to be easy, because you have to remember it's like OpenZeppelin developers are standing behind these contracts, but there are many interesting edge cases that might break the logic. So it would be very interesting. And of course, if you find a bug in OpenZeppelin contracts, what a better PR for yourself could it be in terms of branding? So it's a cool way to break into the ecosystem in terms of like branding and showcase your skills. Anything to add, Monchi?
No, just thanks for having us. The release is live. You got a thread with kind of the main highlights. If there's any question, you can always tag us, or just open an issue on the repo in case you find something that you would want to get improved. As long as you provide like concrete information and info on the use cases, we are always like happy to implement and improve. So yeah.
Thank you so much, everyone, and have a great weekend. Bye bye.